Welcome back to module number 2 differential equation. So in this video we'll discussing on inverse differential operator and particular integral. So let the differential operator capital D is equal to d by dx. Suppose capital D into bracket g of x equal to f of x. So capital D denotes derivative. On integrating on both sides, so this derivative will cancelled out. So g of x equal to right hand side is integration of f of x dx, and this integration is also denoted as 1 divided by d. So 1 by d is nothing but integration. So integration of f of x. So it is called inverse differential operator. And 1 by d square means 2 times integration. 1 by d cube denotes 3 times integration. For example, 1 by d of cos x means integration of cos x. So integration of cos x is sin x. Next one is 1 by d square of x. So 1 by d square denotes double integration of x. So first integration of x is x square by 2. And integration of x square by 2 is x cube by 2 into 3, that is x cube by 6 here. So 1 by d square, 1 by d cube. So these are all called inverse differential operator. So with the help of this inverse differential operator, so we'll discussing different types of particular integral, where we finding the roots of the equation and also writing the complementary function and particular integration of the differential equation here. So first type is differential operator. So types of particular integral. Type 1, if the particular integral is in the form of e raised to ax divided by f of d. So e raised to ax means exponential function. So if the equation is in this form, in denominator term we will replacing d by a. So for example, e raised to ax by f of d. So after replacing d by coefficient of x, so which gives e raised to ax divided by f of a, and here f of a is not equal to 0. So suppose if f of a equal to 0, then we multiplying numerator by x and differentiating denominator term here. So it is applicable only when denominator term is 0. So here e raised to ax by f of d. So if f of a is 0, then here we will multiply numerator by x and differentiated the denominator term here. So f of d become f dash of a, and here f dash of a is not equal to 0. Suppose if f dash of a is again 0, so once again multiply numerator term by x and differentiate the denominator term. So x become x square e raised to ax, denominator is f double dash of a. And here f double dash of a is not equal to 0. So suppose f double dash of a is again 0. So once again multiply numerator by x and differentiate the denominator term. So we'll continue this same process till the denominator is not equal to 0. Note, so here we'll remember it, if the term is in the form of a raised to x, we always expressing a raised to x as e to the power log ax. For example, 5 raised to x, so 5 raised to x is a raised to x form, so its exponential function is e to the power log 5x. Then sine hyperbolic ax. Its formula is 1 by 2 e raised to ax minus e to the power minus ax. Then cos hyperbolic ax is 1 by 2 e raised to ax plus e raised to minus ax. If it is sine, minus sine. If it is cos hyperbolic, sine is plus here. And for any constant k, So constant is expressed as k into e to the power 0x. For example, minus 5 is constant, so it is expressed as minus 5 into e to the power 0x. So now we will solving the examples on particular integral of type 1, that is exponential function. First example, solve d cube plus 1 into y is equal to e to the power x. So right hand side is e raised to x, means problem is belongs to type 1, particular integral of type 1, that is exponential function. So first one we will finding the roots of the auxiliary equation, that is m cube plus 1 equal to 0, and we know that how to calculate the cubic and fourth power of roots here. So already we'll explained by using synthetic division method, or other by using calculator we'll calculate the roots of cubic equation. So the roots of m cube plus 1 is m equal to minus 1 and m is equal to 1 plus or minus square root of 3 divided by 2 into I. So its complementary function is e to the power 1 by 2x c1 cos square root of 3 by 2x plus c2 sin square root of 3 by 2x plus c3 e to the power minus x. So here we'll add one more term, c3 e to the power minus x. So which gives the complementary function. Now particular integral yp. So in the given equation, divide on both sides by d cube plus 1. So the problem takes in the form of e raised to x by d cube plus 1, that is e raised to ax divided by f of d form, and here coefficient of x is 1. So in denominator we will replacing d by 1, so d is replaced by 1. So 1 plus 1 2. So here denominator is not equal to 0, so our required particular integral is e raised to x divided by 2. Then complete solution means we'll adding the result of complementary function and particular integral y equal to yc plus yp. So which gives the complete solution. Next example, solve 6d square plus 17d plus 12 into y is equal to e to the power minus x. So e to the power minus x means again problem belongs to exponential form or particular integral of type 1. So its auxiliary equation is 6m square plus 17m plus 12, and roots of this quadratic equation is minus 4 by 3 and minus 3 by 2, and its complementary function is c1 e to the power minus 4 by 3x plus c2 e to the power minus 3 by 2x. Now yp, that is particular integral. So divide on both sides by 6d square, 17d and 12. And here coefficient of x is minus 1. So in denominator we will replacing d by minus 1. So after simplifying we will get it e raised to minus x divided by 1. So denominator is not equal to 0. So hence particular integral is e raised to minus x. Now add the result of yc and yp, which gives the complete solution. Third example, solve d square y by dx square minus 4y is equal to cos hyperbolic 2x minus 1 plus 3 raised to x. So first one, find out the auxiliary equation of d square y by dx square and minus 4y is m square minus 2 square, that is d square minus 4. So d square is m square minus 4 is 2 square. So now it is in the form of a square minus b square form, a minus b and a plus b, that is m minus 2 and m plus 2. So its roots are plus 2 and minus 2. So both the roots are different. So hence its complementary function is c1 e to the power 2x plus c2 e to the power minus 2x. Now yp, So cos hyperbolic means we will applying the hyperbolic formula for cos here. So already we'll discuss on how to write the hyperbolic function of cos here. E raised to x plus e raised to minus x divided by 2. So according to that 2x minus 1 become e to the power 2x minus 1, that is e raised to x, plus e to the power minus x, that is minus of 2x minus 1 whole divided by 2, and also divide d square minus 4. Then plus one more term 3 raised to x. So 3 raised to x is a raised to x form. So 3 raised to x is denoted as e to the power log 3x divided by d square minus 4. So now e to the power 2x minus 1 divided by 2 into d square minus 4, and e to the power minus of 2x minus 1 divided by 2 into d square minus 4. So in first case substitute the coefficient of x as 2, and second one substitute the coefficient of x as minus 2. So plus 2 minus 2 denominator become 0 in both the cases. So hence we know that when denominator is 0, multiply numerator by x and differentiate denominator term. So after multiplying x e to the power 2x minus 1 and differentiation of d square minus 4 become 2d. Similarly in second case x e to the power minus 2x plus 1 divided by 2d. So now again 1 by 2 is common, so take 1 by 2 as a outside the bracket. So 1 by 2 into 1 by 2 4, and also take this x as common, that is x by 4 here. Now 1 by d means integration of e raised to 2x minus 1. So its integration is e raised to 2x minus 1, denominator is coefficient of x, and here also coefficient of x is 2. Then e to the power log 3x. So here the coefficient of x is log 3. So in denominator replace d by log 3, that is log 3 whole square minus 4. So which is the required particular integral. So particular solution. So after adding yc and yp, which gives the complete. So these are the another few examples on particular integral. 2e to the power 3x. So auxiliary equation is m square 4m plus 3. Its roots are minus 1 and minus 3. Complementary function is c1 e to the power minus x and c2 e to the power minus 3x. Then yp, divide on both sides by d square 4d and 3, and coefficient of x is 3 in numerator. So replace d by 3. So denominator become 24. So denominator is not equal to 0. So our particular integral is e to the power 3x divided by 10. So when the power is 4, d raised to 4 minus 18d square plus 81d. So here also applying the same rule by applying either synthetic division method or also by using calculator. You will calculate the roots of fourth power of equation. So fourth power means it containing totally 4 roots, 3, 3, minus 3 and minus 3. So first 2, 3 are equal, next 2 roots are equal here. So its yc becomes c1 plus c2x e to the power 3x plus c3 plus c4x e to the power minus 3x here. Now yp, divide on both sides by d raised to 4 18d square 81, and substitute the coefficient of x as 3. So simplify, we will get it denominator term is 0. So multiply by x and also differentiate denominator term. So d raised to 4 become 4d cube and d square is 2d. So 2 into 18 is 36d. And once again substitute coefficient of x as 3 in denominator, that is d is replaced by 3. So 108 minus 108, again denominator term is 0. So once again differentiate 4d cube minus 36d. So it becomes 12d square minus 36, and replace d by 3, which gives the 72. So that is the required particular integral. Now add yc and yp, which gives the complete solution. So in particular integral of type 1, if the function is exponential, you will always replace d by the coefficient of x and check it the denominator is whether 0 or not here. If it is 0, then multiply by x and numerator x and differentiate the denominator term here. So you will continue the same process till the denominator is not equal to 0. So which is the particular integral of type 1 result. So in the next video we will discussing on particular integral of type